Hey guys, welcome back. So this is that section we had yesterday, and we got it's fully welded out now. So we pulled this off the car and welded it all out, got everything cleaned with a wire wheel and the welds. So this part here's the front. So that's our V-band that hooks up to the downpipe. We're gonna do like a final polish or something later. But this is it. Straight section, a couple of bends here. This is that spot we had to do to get it to meet up with the piece that goes around the diff. Pretty good. It's not perfect, but it's pretty good. So, happy with this. We're about to install this back on the car with the brace right there. And then once that's in the right spot, that last piece of bracing that goes on the rear of the rear subframe, once this exhaust is in its final spot, we'll build that last brace. I decided to do it that way because I was thinking if I build the brace yesterday, or say I built it today, and then I finished welding the exhaust, if anything moves, I'd have to go back and change that brace again. So since this is already welded, nothing should move. So now we should be able to build the brace and not have to worry about it. Alright, so we've been working on this. We got our measurements, so the center to center for our brace between those two bolts is it's like 15 inches or 14 7/8, something like that. And then we kind of held the brace up in our general position and figured out, we're shifting it this way a little bit, so we kind of figured out how far we need to move it so that we have some clearance to our exhaust. And then I'll show you what we came up with. So this is just a sketch. It's not really to scale, but it's got 1 3/4 wide and something 2 3/4 long. And you can see this is going to go shifted. It's like I said, it's not to scale, but that's kind of what it's going to look like. So here's our metal pieces. We just cut these out on our portaband. I got a DeWalt portaband, and then I bought this company sells a little table that you can actually bolt it up into, and it acts like a miniature vertical bandsaw, which is very nice to have vertical bandsaw capabilities. So basically I just took a caliper and a pen and a pencil and scribed out the lines on the metal to cut this with, and then you just follow the lines with the saw. So it actually, you can see it cuts everything nice and straight. Funny enough, here I'll show you how easy, but yet how well this works. So these are supposed to be 1.75 wide. So that one's around 1.73 there. Right on 1.75. Again, really close. I mean, a few thousandths. So this works really well. You see here, 2.75, again, a few thousandths. So it's a really nice little process. You just scrap them out, run your lines on the saw. You do have to consider the line width. So whenever you draw this, take that into account if you're trying to get it perfect. But yeah, that's a good way to cut out some tabs. Hopefully the actual dimensions we designed are correct. And then I think this is going to go, it's going to go like this. And then the hole's drilled over here. So we did go up on the thickness. So this sheet metal is probably some metric, but it's close to an 1/8 inch from the factory. And this we use 3/16. So we thickened this up because we're going to put this in bending, since it's offset. Before it would have just been in compression or tension or whatever, but now it's got some weird loading since the hole's offset. So we thickened this up to try to help with that. So next we're going to lay out our holes based on our drawing, drill those holes, deburr them, and we'll probably bolt the parts up next and see if we got our dimensions right, see if this fits. Alright, this is just a quick note. I'm about to play a clip in this video, and I'm going to say this steel is 3/4 thick. It's actually 3/16 thick. Sorry about that, I misspoke, and my video editing skills are terrible, so I'm just going to put this in here instead. Alright, so I'm going to show you guys something. It's a bit of a pro tip when you're doing fab work, which is drill bits. So that's an 1/8 inch drill bit, but that's not just any drill bit. That is a cobalt drill bit. And that's not a cobalt drill bit from Home Depot or Lowe's. I bought this from Granger. And it's real cobalt, and it's sharp, and it's actually fairly affordable. I buy these like a dozen at a time. This will be hard to film one-handed, but let me show you how well these work compared to what you're used to using. So this is 3/4 inch hot rolled steel. So I have ground off most of the whatever that's called. But anyway, it's still 3/4 thick. Pretty tough to drill. Sorry, this is gonna go. Let's see if I can hold this up right. I'm gonna attempt to film this while drilling one-handed. One-handed. I don't know what that was, but it didn't take long. It did walk on me slightly, but that's just from doing it one-handed, which there's enough clearance, that's fine. But that drilled easily. You can see it made nice chips. And frankly, had I used two hands and ample pressure, that would have drilled even faster. So it's a definite thing to keep in mind whenever you're working, is having the right tool for the job. And the great thing is that bit probably costs $2.50. So it's not that expensive either. And in this case, we're just doing a pilot hole. You can see we've got another drill bit here. That's a 1/2 inch drill bit. We're going to use it to open this up to the final size. And the reason, this will be the second lesson. So the reason we did the pilot, if you look at the very center of this drill bit, see it's got that weird tip? Those have a hard time cutting. It's called the dead center. So when you use one of these, they don't drill that fast. But if you do that, you put a pilot in there, that really helps. So I'm not going to try to one-hand drill with a 1/2 inch drill bit, because I know that's not going to work. But I thought I'd show you guys this. So using a good cobalt drill bit really makes a difference. And they last a long time too, so they stay sharp. Alright, so I drilled this one with both hands. That took 3 seconds to drill through 3/16 steel. Sorry I don't have someone else to film, or I would have filmed that. But you can see how large these chips are. It was cutting aggressively. Not this metal out here. That's from a different bit. But all that's from an 1/8 inch drill bit. So it's curling up a big chip. I was probably putting 30 or 40 or 50 pounds of pressure on that little 1/8 inch drill bit. And it just punched through that. I counted it down in my head, counted it out, 3 seconds. And it was from start to finish. That's the great thing about a good drill bit. They work really well. Saves you time and cuts the hole clean. You can see there's actually very little bit of a burr. It's another benefit. Let's see if we can see the bottom of it. A little bit of a burr there. I bet you I can knock that off with my hand. No, maybe not. But they cut clean, they cut fast. So just thought I'd show you that. Alright, so we just drilled this one 1/2 inch. This didn't go quite as well. So you can see there are some big chips. That's when I first started drilling. And then if you see towards the, I'll try to zoom, get a better, see that? All the little bitty chips? It was drilling a lot slower. So my guess is this drill bit's been damaged. It didn't really, see how the inside of the hole looks kind of torn? Yeah, it's ripping the metal off instead of cutting it cleanly. So this took probably a minute to drill through, even with a pilot. So that's a bad bit. I need to get a new one. But yeah, this was drilled with a lot of pressure. I was putting probably 100 pounds of force trying to get the bit. You don't ever want a bit to just rub, you want it to cut. So if it's not making a chip, you need to stop drilling and get another bit. This one's kind of, it's definitely at its end of its life. It needs to be replaced. So this is the second one we drilled. Now I knew the drill bit was dull, so we used a lot of pressure on this one. And you'll see that the chips, the chips are larger, more stringy, so basically the feed per tooth was higher. I bet you the inside will probably even look better. That still looks pretty rough. But this went faster. This one cut in probably, sorry about that, this one cut in half the time probably, just from really pushing on it hard. So we're going to take this burr off. You can see it's got a sharp edge, and we got a step drill. We're going to try to one-hand this and show you how well these step drill bits work at moving dirt. So the bit shaking, that's just from one-handing the drill, but puts a nice bevel on it, gets rid of the sharp edge. Very nice. Look at this. Good news to report. So The fitment is incredible. So I basically got the dimensions like we showed with that caliper. We really got this right. So it all fit. I mean, it's actually just friction holding it up there right now, but you can see that bracket straight, this bracket straight, and it's just towed in, holding it with friction right now. See right there, we're obviously got to weld all this together still, but this looks like it's going to work. And let me show you from this side. Look at that. This isn't quite perfect. That curve, it's a little tighter at the top than it is at the bottom. You can kind of get a perspective there. So it would help to bring that top in a little more on that tube. But it does have well over 1/4 inch of clearance there, so quite a bit. So I'm happy with that. This looks like it's going to work. So now we'll pull this off the car and weld this all together. Alright, so I did see one oversight before we weld this. If you look here, that corner doesn't need to be hanging off right there, but it is, and that's getting close to the exhaust. It's still got maybe 1/4 inch of clearance, but there's no need for that to be there, so we are going to trim that corner to give ourselves some space. But on this one, on the passenger side, it's not an issue since there's no pipe there. But since there's a pipe over here, I guess this is exaggerated as compared to this side since we trimmed all of this. But yeah, we'll knock that corner off too. Alright, last thought on this before we weld it. So I thought, right before I took it apart, I was thinking, how am I going to hold this when I weld it? And that's going to be a problem. I need it to be, held exactly. So it's actually, what I'm going to do is I'm just going to bring the welder over here and we're going to tack weld it while it's on the car. This is beneficial. One, it holds it for me, and two, I know it's all tacked in the right spot, so I don't have to worry about whether this is going to fit after welding it in case I did something wrong holding it. So yeah, we'll bring the welder over here, tack it up in place, and then we'll unbolt it and we'll weld it out on the table. Alright, we just got done tack welding this, so now it's in position. Show you that. Just 3 on the top over here, and yeah, they're not that great, but kind of awkward to get to. This one had a pipe on top of it as well. Yep, they're tacked in, so now we know the alignment's good. We'll unbolt this and weld it out. Alright, I figured I'd show you how we're setting this up to weld. So I don't actually have a welding table. It's on the list. We got to get one, but for now I have this little plywood janky table that we're using, and I've got some steel plates that I just basically welded together to make a little section, and some other plates that I use to hold stuff. So you can see here we got one laying on top of this bar so it doesn't flop around on us. So yeah, that's about it. We kind of got this comfortable where I can sit here and this is ready to weld. So we've got, I don't even know what the welder settings are. I think we're at 110 amps, something like that. Really don't even know if that's right, but it works. So here we go. So here we go. We just did a fusion weld. Well, we kind of did a tack to get the puddle going, but then fusion welded it top and bottom. So here we're kind of going for trying to get full penetration. We're going to put a cap on top of this for strength. Here's the bottom side. As you can see, it's not really proud of the surface, but this is so that the underlying part is strong, and then I put a cap on top for strength. Alright, here we go. So we just got this welded. The welding didn't go as good as we'd hoped. Don't even know why, to be honest. These are the better looking welds. And it didn't, I don't know, I'm sure it did something wrong. But this is what we got. It should be okay. It's just a brace. But there we go. See, those welds aren't as nice. Yeah, I don't know what was happening. It was, whenever I tried to weld, it kept popping. And the metal would jump up onto the tungsten. So, don't know. But we got this made. Now we're going to go, hopefully, bolt it up. Hopefully it didn't warp and still fits. Alright, good news. This brace fits. We did forget to clearance that spot by the exhaust, but we fixed it. Here we go. Got it bolted up. Got our exhaust past the diff. Our braces are finished. Got a little clearance there, and we can always trim that piece if we need to. But you can see, looking over this, look at that. Good amount of clearance for that. This tube up here, that's got clearance. So we are good to go. You can see here, I'll line the camera up. So you see those two original braces? Come up to where it's level, you can tell the pipe barely lower than that. So it is low, it's lower than this original tube for sure, but it kind of had to be, unless I made this brace angle out or something. So we're going to try this and see what it gets us, but for now this is what we're running. So